Let's look at a very special case of the Pythagorean theorem on an isosceles right triangle. First, the Pythagorean theorem says this: if you have a right triangle with side lengths a and b and hypotenuse c, then a squared plus b squared will equal c squared. To calculate c, you take the square root of a squared plus b squared. Now, in the isosceles right triangle case, two of the sides, or the legs, are exactly the same. So we both have side lengths a. And that means that a squared plus a squared equals c squared. But now we can combine these and say 2a squared equals c squared. Now we take the square root, and so we can say that c is the square root of 2a squared, but this can be reduced into a times the square root of 2. And now something really neat exists, a relationship between the sides, the legs, and the hypotenuse. It turns out I can replace c, get rid of it altogether, with just a times the square root of 2. So if I know the legs, all I have to do is multiply a leg by the square root of 2, and I've got the hypotenuse. So let's just look at a specific example of that. Here I have the legs, 8, 8, and then the unknown hypotenuse. Well, I could start like normal. I could say 8 squared plus 8 squared is c squared. And so that's 64 plus 64, which is 128, equals c squared. Taking the square root, I now know my hypotenuse c is the square root of 128, but that can be reduced into what? 8 times the square root of 2. So really, I didn't have to go through all of this. All I had to do was take the leg number and multiply by the square root of 2. So 8 times the square root of 2 is approximately 11.3137085. This is an irrational number, so there's no way we're going to have all the digits, but we do have a very good significant number of digits. And so, yeah, that's the special relationship that exists in an isosceles right triangle between the legs and the hypotenuse. You actually don't have to go through the whole Pythagorean theorem to figure out the hypotenuse. Just take the leg number and multiply it by the square root of 2. Hope this was helpful. God bless you, wherever you are today.